Hey guys, welcome back to a slightly different video for GCSE Maths. I'm going to be going through, in particular, this 2023 Paper 2 really hard question that was at the end of Paper 2. And a lot of students kind of found it a bit confusing, and then obviously when you see on social media everyone going, oh my god, how the hell are you meant to do this? I'm going to take you through exactly how you can approach a question like this and try and get at least some of the marks. So bear in mind this is a 5-mark question, but getting a few marks is actually not too tricky. But they also like to do this most years. So practically every year they have a question that's geometry and it's quite tricky, but when you actually break it down it's not too bad. I've done quite a few of the other ones on my channel already, which you can search for if you want to, but it's really easy to get a few marks. And the reason why I want to focus on this in particular is that it's not really a grade 9 topic. It's geometry, and you're going to see that we're going to be using Pythagoras, the area of a square, and the area of a triangle. Those three things at best are grade 4 or 5. But if you put it all together and you make the question quite tricky, of course it becomes a little bit more difficult. But before we get started, a lot of people watching these videos aren't subscribed, so if you wouldn't mind just hitting subscribe if you find any of this useful. And of course visit my website / use my email in the description if you have any questions or you want tuition or anything like that. But without further ado, let's jump straight into something like this. Now, another question that I get is, well, I'm only aiming for a grade 4 or 5 or 6 or something, so why should I do the really hard questions at the end? And fair enough. I understand that, if you want a grade 4, you only need 20% of the marks. That's a fact. If you want a grade 5, you only need between 30 and 40%, depending on the year. Again, that's a fact. If you want a grade 6, again, from like 35 to 45%. Yeah. So why bother doing the ones at the end? Well, every year, the people that kind of aim low, so let's say they're aiming just for a pass in the higher tier, they sometimes miss it by a few marks. And those few marks you could get from a question at the end. So some of them will only do the first half of the paper. And when they study, they only do the first half of the paper. The problem is that limits how many potential questions you can get right. So in a paper, there's roughly 21-ish questions. So let's round it down to 20 to make it easier. If you only focus on half the questions, that's 10 questions. So if any of those 10 questions are hard, you kind of screwed yourself out. So let's read this. So we have 8 regular octagons joined to enclose this kind of weird star shape in the middle. Each octagon has a side length A. Find in terms of A an expression for the area of the shaded shape. Give your answer in the form blah 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 blah. So they've shown what the answer is going to look like, where P is going to be some kind of integer. We have the 2 plus root 2. Then we have A squared as well. So essentially what we're trying to work out is the area of this shape. Now this shape, it does have a name, of course, because it's a something-sided shape. I'm not even going to bother counting it, but this is a compound shape. If you have a look at this, what shapes could I break this into? Well, the thing that I spotted almost immediately was I could cut off these pointy bits, because the pointy bits are making it hard. If I cut off all of those pointy bits, I get a 4-sided shape in the middle. I don't know if it's a square yet, so I'm not going to assume it's a square. And we have 4 triangles here. Again, I'm not going to assume anything about the triangles, but it is just going to be 4 triangles, and I would argue that these are identical. And we have a 4-sided shape, and I'd argue that this is a square, but I'm going to show you that in a second. But for now, it's a 4-sided shape and 4 triangles. And how do you work out the area of a 4-sided shape? You just do the base times the height. So we're going to find the width or the base of this shape, and I'm going to times it by how tall it is. And with the triangle, it's just base times height over 2. So we're going to times the 2 sides and divide it by 2. That's it for the area, then you add it all together. So again, that's not too tricky just yet, but now we need to actually work out what the sides are. So let's decide some stuff. The first thing is they tell me it's 8 identical regular octagons, and they have side A. So all of these sides here, in fact, let's write it in a different colour to make it stand out a bit more, are A, 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 and A. And even the diagonals of each triangle are side A. So, what do we know? Well, whatever this base length is here, it's also going to be the same for all of these sides, isn't it? Because we have, if you remember your congruent triangles, we have 2 identical sides, and the angle between them is also going to be identical, which means side, angle, side, all 4 of these triangles are identical, which means the lengths of this 4-sided shape are all identical. So now what I'm going to do is I'm actually going to get rid of some of this to clear it up, and I'm going to say this. all I need to do is work out, let's call this number 1. We need to work out the side of the square and then square it to get the area. And the second thing we need to work out is we need to work out the area of one triangle and we're going to times it by 4. Right, so I've shown you that this is indeed a square and these triangles are all identical. So now let's simplify it a bit. Now, here's the interesting thing. If I zoom in a bit, this triangle, it kind of looks like a right angle triangle, right? Which, if it is, would help us a lot, because to work out that third side, we could just use Pythagoras, which is really, really nice and easy. So if I just quickly get rid of that for a second, I'm going to show you why it is indeed a right angle triangle. If I continue this line going down, let's use blue. If I continue that line going down, these angles here are the exterior angle of the octagon. And how do you work out exterior angle again? You do 360 divided by n. And this is an 8-sided shape. If you do 360 over 8, you'll get 45. But remember, this is paper 2. So we can absolutely just use a calculator to confirm that fact. 360 divided by 8, 45. Now, I know what you're thinking. Well, hang on, that's not 90 degrees. Well, don't forget, each of these sides, each of these parts of the angle are 45. So what is that in total? 45 plus 45 is indeed 90 degrees. So this is a big, fat, right-angled triangle. So now working out the area of the triangle is actually pretty easy, because we can just do a half times A times A. So we can fill that in right now. A half A times A, which is A squared over 2. Then because we have 4 of them, we're going to do A squared over 2 times 4. Already, just so you're aware, I've already gained 2 marks. Already. All I've done is I've worked out the area of a triangle and times it by 4. That's it. So, we can, I guess you can say we're technically halfway there, right? We've got the area of the triangle. Now we just need the area of the square. So, how can I work that out? Well, this opposite side, because it's opposite the right angle, is the hypotenuse of this triangle, which means this blue length is just going to be, if we use Pythagoras, going to be A squared plus another A squared equals that opposite side there, which, let's just call it x for now, x squared. Which means we have 2a squared equals x squared, which means x is equal to square root 2a. So that's what that length is there. So the side length now is going to be a plus square root 2a plus a, which of course is, if I scroll across, is 2a plus root 2a. Now this actually looks a bit familiar, because if I look at the answer for a second, there's this 2 plus root 2 here. So what I'm going to do is I'm going to factorise out an a. I'm going to say that this is actually 2 plus root 2a. All I've done is I've factorised out the a, and I've actually got part of the answer already. So now, if I write area of the square, what will that equal? It will just equal this whole thing. Okay, we're going to have 2 layers of brackets. The whole thing squared. And how do I want to write this? I might leave it as 2 plus root 2 squared a squared, like that. And then all we need to do is simply add these two things together. So that the total area is just 2a squared from here plus 2 plus root 2 squared a squared. Now if I'm looking at this, I'm actually thinking it might be worth, I'm thinking of 2 different things at the moment. What would be smart? I'm going to expand this bracket. So what I could do, just so you're aware, it's a bit of fancy algebra, but I could factorise out a squared. So I could have 2 plus 2 plus root 2 squared, a squared, and then I could expand that bracket and simplify in order to get something that looks like this. That's something that would work. Is there anything else that might be smart? I think that might be the best way. I could have expanded the whole thing here, but then it's going to be quite long, it's going to be quite ugly. So let's just expand this interior bracket. So we have 2 plus, we're going to have 2 squared, which is 4. We're going to have 2 root 2 plus another 2 root 2, which is 4 root 2. And then root 2 squared is 2 again. So that equals 2 plus 4 plus 2 is 8. Plus 4 root 2, a squared. Now if you notice, if you look at the answer, what's the difference? Well, the bracket should just be 2 plus root 2, and they factorize something out. They factorized an integer out. And if I have a look at this, I could factorize out a 4 and get 2 plus root 2 a squared, which is in the exact form that they're talking about in the question. Now again, I think this last part is probably the hardest bit. I'm going to call it algebra because it basically is algebra, but it's also some surds. It's a little bit hard to manipulate that. But in terms of getting the first 3 or so marks from doing this, I don't think that's too crazy. So working out the side length gives you a mark. Working out the area of the triangle times by 4 gives you a mark. Working out the area of the square gives you a mark. I think that's reasonable. This part is probably a bit trickier, and maybe a few of you maybe got a bit lost there. But hopefully you can see that overall, questions like this, and again, I have the other versions on my channel as well, where you have like circles everywhere or like pentagons everywhere or all kinds of crazy stuff. But hopefully you can see it's not actually that bad, hopefully. But anyways, I hope that you kind of gain something from that and you kind of see how you can break down these questions into bite-sized chunks, which again, you're only aiming to get a few marks on this question. You don't need to get 5 out of 5. Getting 3 out of 5 means 60%, which is a very strong grade at GCSE. But yeah, hopefully you found that useful. Again, please do consider subscribing, and I'll see you in the next one.